Variable roof slopes can go from very low to very high and anywhere in between. The slope of the roof will usually be given on the plans using some variation of the slope triangle as shown here. Different parts of the world express the same slopes in different ways. Most countries use some variation of rise to run, but some places in the world also use degrees for roof slopes. We'll have a quick look here at how to interpret all the different systems used around the world to express roof slopes and how to move back and forth between them. Describing an angle as a fraction of the number 12 goes way back to ancient times, when medieval astronomers and surveyors used fractions of 12 to show the tangent ratio on their astrolabes. But it wasn't until the 1880s, when the steel framing square started being mass-produced in the United States, that inches of rise per 12 inches of run became the common method of describing roof slopes in North America. Here's how it works. Rise is always given first, and run is always 12 inches. So 3 to 12, rise is 3 inches over 12 inches. 6 to 12, rise is 6 inches over 12 inches. 9 to 12, rise is 9 inches. 12 to 12 is a 45-degree angle. And 18 to 12 or 24 to 12 indicates a very steep roof. Inches of rise per foot of run is universally used today in North America. But before the advent of the steel framing square, carpenters used an older system where the pitch of a roof was expressed as a fraction of the rise over the span. We'll have a look at fractional pitches later on at the end of the video. In North America, we see percentages used to express the steepness of roads and ski hills, but around the rest of the world, it's the most common way to express roof slopes. It's a rise over run system where the run is always 100. One thing to keep in mind if you're new to percentages is that 100% slope, or 100 units of rise to 100 units of run, is a 45-degree angle, not a vertical line. This metric rafter layout square has a scale for marking plumb cuts on rafters from 10% up to 300% slopes. Pivoting the corner of the square around the edge of your lumber and lining up the number 2 in the common rafter scale will give you a plumb cut for a 20% slope. Percent slopes are interchangeable with the decimal slopes used in some countries, including Japan, which use units of rise per 10 units of run. Aligning the number 30 on this rafter square will give a plumb cut for a rafter with a 30 to 10 slope, which is the same as 300%. The Canadian Building Code uses a rise to run ratio called gradients to express roof slope. And if you see some odd numbers in there, it's because these are direct equivalents of the feet and inches system used throughout North America. In contrast to the other rise and run systems in the world, these gradients use a constant rise and a variable run. Here's how it works. 1 to 1 has both a rise and run of 1, making it equivalent to 12-12, 100%, 10 to 10, or 45 degrees. 1 to 2 has a rise of 1 and a run of 2, making it equivalent to 6-12, 50%, 5 to 10, or around 26 degrees. 1 to 4 is the same as 3 to 12, 25%, 2.5 to 10, or around 14 degrees. Of the many different ways that are used to express roof slopes, the tangent ratio is definitely the most useful of all of them, but it's one that very few carpenters use. Put simply, a tangent is the rise of a slope per single unit of run. The name tangent comes from the trigonometry developed by ancient astronomers, and tangents have long been used for surveying and navigation. For carpenters, the tangent ratio is the single most useful way to express rise and run, because the tangent, multiplied by any run, in any units, is equal to the rise for that run. The good news is that any rise and run system can be quickly reduced to the tangent ratio just by dividing the rise by the run. Whether your slope is given in gradients, percent, decimals, or rise over 12 inches, just divide the rise by the run and you'll have the tangent. In the UK and Scandinavia, construction plans use degrees to specify roof slopes. This simplifies angle cutting with miter saws and marking with speed squares, but it complicates using the step-off method or calculating a line length. British carpenters use this reference book to convert degrees to rise and run and to find line lengths. But with a couple of keys on a pocket calculator, you can quickly find all the information you need. The tan key will convert degrees to the tangent ratio, which is rise per single unit of run. And the arctangent, or tan to the -1 key, will convert any tangent to degrees. Here's a couple of examples. Say your plans indicate a roof slope of 35 degrees. Punch 35 into your calculator and hit the tan key. You'll get a result of 0.7. That means that if the run is 1 of any unit, the rise is 0.7 of those units. Multiples of this tangent give us 7 to 10, or 70%. Here's a 42 degree slope. Put 42 into the calculator, hit tan, and you get 0.9, which is 0.9 units of rise per single unit of run. In other words, it's a slope of 9 to 10, or 90%. Now, if your slope is given in rise over run, but you want to get it into degrees, use that tan to the -1 or arctangent key. For a 50% slope, divide 50 by 100 to get a tangent of 0.5. Hit the arctangent key and it shows 26.5 degrees. For a 1 to 1.5 slope, divide 1 by 1.5 to get a tangent of 0.6 repeating. Hit the arctangent key and it shows an angle of 33.7 degrees. For a 12-12 slope, divide 12 by 12 to get a tangent of 1. Hit the arctangent key and it shows an angle of 45 degrees. Carpentry textbooks and carpenters with English degrees spend a fair bit of time arguing about the correct usage of the word pitch, with several current textbooks insisting that the only correct use of the word pitch is to refer to the total rise over the total span of the roof expressed as a reduced fraction. For example, 1/6 pitch means a roof with 2 feet of rise over 12 feet of span. It's always mystified me as to how that system could have possibly ever been a useful or convenient way of describing a roof slope. So for this video, I did a little bit of digging. It turns out that back before the steel framing square with tables of roof calculations on them started to be mass-produced in the USA in the 1880s, carpenters in North America worked out all of their roof cut angles using scale drawings and descriptive geometry. In that system, all of the cut angles are lifted off of the drawing board and transferred to the rafter stock with a sliding T-bevel. It's when you're making these development drawings that rise over span clearly emerges as a more useful and convenient method than rise over run. The rise and the span are the first pieces of information you need when you're constructing this type of drawing. Once the steel framing square, complete with rafter tables, arrived, geometry, drawings, and sliding T-bevels became unnecessary for all but the most complex roofs, and rise per foot of run became the standard for the American residential building booms of the 20th century. This New York carpentry textbook from 1899 comes from the transition time, when the steel square had only been around for a decade or two. It makes a couple of things clear. First, pitch is just another word for angle, slope, or inclination. And second, the system of rise over span, was already considered obsolete and impractical well over a century ago. How and why current carpentry textbooks still contain the relic of pitch, meaning fractions of rise over span, all these years later, is a bit of a mystery. But it's one that the vast majority of carpenters happily ignore. And if you hear any carpenter using the word pitch in this century, they're talking about rise to run, not rise to span. As for using descriptive geometry to determine rafter cut angles, carpentry apprentices in Korea, France, Germany, and Switzerland still learn and practice these techniques, which is why you can see them get medals year after year in the World Skills Carpentry Competition. Thank you for watching this video on roof slopes. I hope you found something that will help you out on the job site.